Okay, we'll talk next about language. Okay. So language has different parts to it. You have to read it, write it, hear it, and comprehend it. And so different brain regions cover these particular things about language. So let's begin by identifying some areas of the brain that are involved in language processing. So first is speech. So there's something called, so this is your the brain, like this. All right, that's the brain. Okay, we have frontal lobe here. Here's the parietal lobe. Here's your occipital lobe. And here's your temporal lobe, okay? So in the brain, in the frontal lobe, towards the side of the frontal lobe, you have an area here like this. This area here, we call Broca's area. And that part of the brain, usually in the left half of the brain, is the right side, so usually in the left half of the brain, Broca's area is what we call your speech area. It's the one that will create the muscle movements required to create speech. So it creates the command sequence necessary to make speech. So the Broca's area will then send this command sequence over to your primary motor cortex, which will in turn then send the commands to your speech muscles. Things like your larynx, your tongue, palate, those things are involved in speech. So their movements are based on the commands sent from Broca's to the PMC, primary motor cortex, which then sends down, again, through two neurons to your speech muscles to make speech. That's Broca's area. Then there's another area in the brain that is right in the area of the parietal, occipital, and temporal lobes. Those three lobes where they meet, that junction area we call your Wernicke's area. Okay. And this area, again, located in the junction of the parietal, occipital, and temporal lobes, again, usually on the left side of the brain, is your language comprehension center. Okay, so when you see words, see words, or hear words, or even touch words, okay, like Braille, for example, that information is sent to this area where it's interpreted. So when this area goes bad, you're unable to recognize words because that's where you store your vocabulary, basically, in the language comprehension center. It also is what will send words over to Broca's to be said in order to convey a meaning. So you have Wernicke's and Broca's. Then in the area of the brain on the opposite side of Broca's. So Broca's is on the left side. The area on this side that's opposite of Broca's over on this side is called your affective language area. Okay. That part is opposite Broca's. In the same exact area, just in the other hemisphere. And it allows for you to put emotions in speech. Okay, so when you speak and you're happy, you can feel it, see it, hear it in your words. When you're mad, you sound mad. You can tell because you can put it in your speech. Individuals who have a damaged affected area or have what's called flat speech. It's called a prosody. That's just flat, monotone speech. Hello, how are you doing? And you can't tell what's going on. There's no emotions there because this area is not working. So this is the area that allows for you to input affect into your language. And then opposite of Wernicke's, you have your, it's not really given a name, but this is the area that you use to comprehend the emotions or affect in language. So if Wernicke's is here, this part is over here. It's not given a name, but it's the area opposite Wernicke's. Okay. So this is the area that we use to get a joke. So, to get sarcasm, for example. Those things are language subtleties that you have to pick up. You may learn it culturally, but after a while you recognize it because you have this part there. You can pick up emotions in speech. Okay, so don't forget those 4 areas of the cortex and what they do. Then you have, so between Wernicke's and Broca's, so here, axons must travel from one area to the next. I'm trying to find a good marker here, different color. So let's look for green. So axons must go from here, Wernicke's, it's blue, great. My name. Axons must go from here over to Broca's. So all those axons that carry the words over from Wernicke's to Broca's, they form what's called your arcuate fasciculus. So that's a bridge of axons that join Wernicke's to Broca's. Your arcuate fasciculus. Okay? And so sometimes you have damage to different parts of the brain which are involved in language. So let's look at some of these outcomes that happen when you damage the brain or have something that goes wrong in the brain. So let's begin with lesions. So these are called aphasias. Aphasias are deficits in language that are created by a lesion, damage to some part of the brain. You may suffer an injury, or you may have brain neuron loss in certain side of the brain, and that will affect your language. So there's an aphasia called non-fluent aphasia, also called Broca's aphasia. Okay? It's caused by damage to Broca's area. And in this case, the person who's suffering from non-fluent aphasia it has slow or difficult speech. Almost looks like stuttering in some way, okay? Especially severe stuttering. But it's not the same cause though. So here, slow, difficult speech, where you're stuck on a word, you may even approximate the word with another word, just to get speech moving. That is what non-fluent aphasia looks like. Then you have fluent aphasia. Also called Wernicke's aphasia. In this case, you've damaged Wernicke's area, and now you speak fluently, but you use the wrong words. So speaking basic nonsense words, nonsense structure. Because Wernicke's is damaged, you cannot select the right words to use to convey a meaning. So you just toss words out. Like if you want to say, I I'm tired, you would say sky, green, blue. Just using random words. So it sounds fluent, continuous, but it's nonsensical speech, okay? That's called fluent aphasia, when it is damaged. Also, individuals suffering this kind of aphasia also cannot comprehend words, okay? So can't comprehend words either. You see something on the page, you're driving in your car, the sign says stop, and you drive through the sign, okay? Because your Wernicke is not working, it's damaged. Another aphasia, what we call your conduction aphasia. So in conduction aphasia, here, the bridge between Wernicke's and Broca's, that bridge, remember the arcuate fasciculus? This bridge is damaged. So when that's damaged, the words cannot get over from Wernicke's to Broca's. And it says due to damaged arcuate fasciculus, and the symptoms are like Broca's. So it has your Broca's aphasia symptoms, where again you're stuck in your speech because the words are not coming over to you. So you're stuck, you're slow, you just struggle to get the speech out. And then there is another condition called anomic aphasia. Here, you can read and speak normally, but you cannot identify words. You cannot identify written words or pictures. So can't identify words or pictures. I may show you a picture of a car, and you would say, okay, I know what it is, but I can't say it, right? Because you can't make the call. The picture does not create words for you. It doesn't get sent into the Wernicke's, and the library doesn't properly internalize it to make a word for you. Okay, so you're stuck there. That's called anomic aphasia. Okay. All right, so that's language. Let's next switch gears and go over to what's called cerebral lateralization. So you have so cerebral lateralization is this phenomenon where one side of the brain does something better than the other side of the brain. So where some things are done better on one side versus the other. So it's said to be lateralized. Okay, so here if you have two halves of the brain. Let's make this half your right hemisphere, this half your left hemisphere. Okay. In general, the left hemisphere is what we call your categorical hemisphere, and the right one is what we call your representational hemisphere. All right, so the categorical hemisphere is the hemisphere that does logical things. Okay, it's your math hemisphere. It's also your speech hemisphere. You speak from this side. The categorical side is also your language side. So speak and comprehend from the categorical side, okay? And then your representational side is your artistic side. So musical abilities over here. Okay? Your drawing skills, your intuition. Okay? What do we got here? Intuition. Okay. So your artistic side is housed in the representational hemisphere. And for most people, this is the case, where the left side of the brain speaks for you, comprehends words, does your math. The right side does your artistic stuff. Okay, so someone said to you, you are so left-brained. They're trying to say that you're very logical. You're so right-brained. They're trying to say to you that you're very artistic. Okay. Now, this is true in I think 96% of right-handers will have the categorical hemisphere on the left side. This is only true for around 70% of left-handers. All right, so there is some handedness to it where most right-handers speak from the left side of the brain, while only 70% of left-handers do that. So there is a little disparity between right-handers and left-handers there. Okay. Also, this lateralization idea or phenomenon is more true in males or more lateralized than females. So if a male has a damaged left hemisphere, they may lose speech more easily than a female would, who may have both hemisphere being able to handle speech better. Okay? And adults are more lateralized than kids. Okay? So please note that information on cerebral lateralization. Okay, we'll stop there. That ends the lecture on brain functions.